talk about a condition that is called atrial septal defect. And that might sound a bit complicated, but it really isn't. Let's break it down one step at a time. Atrial, of course, we're dealing there with the right and left atria. So that's the first word. Septal. A septum is a wall. And we have a wall right here in between the left and right atria, so that makes sense too. And if we have a defect, we have some type of a structural abnormality. And with atrial septal defects, what we are usually dealing with is a hole in the wall. So we have a hole, which is a defect, in the wall, which is the septum, and it's going to be between the left and right atria. So it all makes sense. So over here we have our right atrium. Over here we have our left atrium, and of course we have our right ventricle and left ventricle. We're not going to focus on those in this video, but just want to mention that really quick. All right, so if we have a hole in the wall between the left and the right atria, what's going to happen? Well, this left side of the heart, it's doing a lot of work. It's sending blood all throughout the body, literally all throughout the body. It's going, in this direction. It's going to the head, it's going to the upper extremities, and then it's also going down to the lower extremities. It's going everywhere. So this side is going to be significantly stronger than this side. Significantly higher pressure on the left than we have on the right. Because the right, where are we going? Well, it's taking this deoxygenated blood and it's going to our lungs. The lungs are right here. Let me draw in a lung right here really quick. So this is my lung. It's not far. It's not a huge distance it has to travel. So we have lower pressure on the right side. So as a result of that, what we're going to end up in an individual with an atrial septal defect is we're going to have blood kind of squeezing in through that opening and going from the left atrium to the right atrium. And of course, if you have some blood squeezing there, it's going to continue on the path that it normally travels, and it's going to go back to your lungs. Now, in terms of the positioning, most times we have the atrial septal defect kind of right here in the middle. And that has to do with the fact that, when you look at the heart when it's developing in the embryo, this wall isn't there in the beginning. But when it comes, there is an opening that allows for blood when it comes back from the placenta, because it's getting oxygen from the mother. That's going to bypass the lungs because the lungs aren't functioning as yet in that developing embryo. So it's going to bypass the lungs, and one of the ways it does that is by going through this opening. So if that opening fails to close, it's supposed to close, we want it to close, and that closes soon after birth. But if it fails to close, we can get an atrial septal defect, and this positioning is called ostium secundum. All right, so that's the position, that's the place where we usually have it, right there in the middle of the wall, and that is considered ostium secundum. But it can also be lower down. So if we were to have, a hole down here, let's make sure I have that selected. Okay, so if we have a hole down here, to the point, maybe it even involves this valve between the atrium and the ventricle. Well, what that is considered to be is, let's draw that over here. Let me do it in a different color just to be fancy. That is going to be ostium primum. All right, so that's lower down. That's not generally seen, but it is seen in some individuals with Down's syndrome. This is going to be the most common congenital heart defect, and congenital, it just means that individual is born with it, but that's going to be the most common congenital heart defect in people, in babies with Down syndrome. So what are the signs? Well, it's usually, okay, let's just put over here, signs. It's usually asymptomatic. So number one, let's just put asymptomatic. And the reason for that is, okay, you have a hole in the heart. It sounds like a huge deal, but it's not necessarily a huge deal because that's just going to get a little more of that oxygenated blood going back to the lungs. but the oxygen levels are still relatively fine. They're adequate for normal function, so we don't generally have problems. But another thing that we can see in individuals with atrial septal defect is what's called a paradoxical embolus. Paradoxical embolus. And what that is, let's say, I'm going to just draw this simply. This is somewhere in the body. And let's say here we have, since I'm drawing a blood vessel, I'm going to draw the blood vessel in red. So here we have a blood vessel. It doesn't matter what blood vessel it is. And this blood vessel is in the legs. And in that blood vessel, for some reason, we get a clot. There's some kind of damage that causes a clot to form. As the blood is rushing through there, a piece of that clot might break off, and that clot can travel back to the heart, going through the right atrium and right ventricle. And normally, what can happen is that that clot gets stuck in the lungs, and there we have a pulmonary embolism. But in individuals with an atrial septal defect, that can potentially give that clot or that embolus a different direction, a different route to travel. Now, that's not usually going to happen because, of course, higher pressure over here in the left, pushing towards the right. So the stuff isn't necessarily going from the right atrium to the right ventricle. But let's say that individual is straining to do something and they're bearing down, or let's say even that individual goes to the restroom and, they go to take a poop. And when they go to take a poop, of course, they're applying a lot of pressure, and that applies pressure on this side. And if that increases above the left side, that can cause that clot to travel into the left side, and then via that left side it can go via these major vessels and possibly even go to, this is a terrible attempt at a brain, and imagine if it's going to a blood vessel that's going to the brain. What can that cause? Well, that can actually cause a stroke. So it's not usually a problem, but you can see how it can potentially be a problem if there's a clot that then travels to the left atrium and then goes to the rest of the body, possibly even going to the brain and causing a stroke. Now, how these atrial septal defects are normally noticed, at least at first they're noticed because, when the baby is born, I remember when my son was born, one of the first things they did is the nurse took a stethoscope and she listened to the sound of the heart. And when she listened to the sound of the heart, fortunately, it sounded fine. But one of the ways that you can detect this is when you listen to the sound, you hear something like, you're supposed to hear lub, dub. So let's say this represents those two sounds, lub dub. Now this first sound is going to represent the closing of the valves between the atria and the ventricle. So this valve right here between the left atrium and left ventricle, and then this valve over here between the right atrium and the right ventricle. That's the lub sound. That's this first sound that you hear. The dub, the lub dub, this second sound is going to be because of the closure of two other valves. The two other valves would be this pulmonary valve here going into the pulmonary vessels, and this aortic valve which the blood goes through to lead into the aorta. So this dub is the closure of these two valves. Now, with an atrial septal defect, what you have, because blood is going to be shunting from the left to the right, we're going to get an increase in the amount of blood that's going to the right side. And because we get that increase, we're going to get an increase in the blood that's going to the pulmonary circulation. And as a result of that, we're going to get this valve closing just a little later than this valve. So what's going to end up happening as a result, if we look at this second sound, it's going to look a little different. Now, this isn't going to be 100% accurate, but it's going to illustrate the point. It's going to look a little different in that we are going to split this second sound. So it's no longer a lub dub, it's a lub drub, because the pulmonary valve is closing just a little later than the aortic valve resulting in this split sound. So that's pretty much what you get with an atrial septal defect. It is usually ostium secundum. It can be ostium primum, especially in individuals with Down syndromes. Usually asymptomatic, sometimes resulting in a paradoxical embolus, which can potentially lead to a stroke. And when you listen to the sounds of the heart with a stethoscope, you get this split S2.